In this video, we're going to talk about the chain rule. Our objectives will be to find derivatives of basic functions using the chain rule, to identify inner functions and outer functions for composite functions, and then apply the chain rule to find their derivatives, and then use the chain rule multiple times, and use the chain rule with product and quotient rules to find derivatives, and then find higher order derivatives using the chain rule. So let's talk about the chain rule. Suppose that we have y equals a function of u, where u is a function of x that we're going to call g of x and is differentiable at u equals g of x. And u equals g of x is differentiable at x. The composite function y equals f of g of x, or y equals f of u, is differentiable at x and is differentiable, and its derivative is expressed as follows with the chain rule, that dy dx is equal to dy du times, and then normally we would say du dx here because u is equal to g of x, and we would imagine that this du and that du almost cancel each other, like if they were a common factor in a fraction, and you'd look at your differentials there, dy and dx would remain to give you dy dx. These are not actually fractions. These aren't factors, but you can say here dg dx, and that's also correct to say that, since g is the same thing as u, but we're usually going to say du dx. So we see this kind of cancellation here in the chain rule. All right, let's go ahead and review function composition, identify f and g, the outer, this is the outer function, and inner function for the following functions. So first, we're going to have outer function f of x is equal to x squared. Something is being squared, and the something that's being squared is x plus 1. And then we have outer function here is the square root function, and the inner function is 3x minus 4. Now we want to differentiate using the chain rule, where we have, and I'm just going to use u substitution here. It's going to be something that's going to be important for us to know later. So this is going to be u equals 5x plus 4, and u prime is going to be 5. We say y equals u to the 3 halves, y prime equals 3 halves times u to the 3 halves minus 1 times u prime. So y prime equals 3 halves u to the 1 half times u prime. Y prime equals 3 halves. U is 5x plus 4 to the 1 half times u prime is 5. Y prime is 15 halves times 5x plus 4 to the 1 half power, and I'm going to leave that as a fractional exponent because I started off with a fractional exponent. You could also say y prime equals 15 halves times the square root of 5x plus 4 because 1 half power is the same thing as a square root. Let's go ahead and make u equal to 6x to the third plus 3x plus 1, and u prime is equal to 18x squared plus 3. Y is going to be equal to u to the 10th power. Y prime will be 10 u to the 9th times du dx, or u prime. So y prime is equal to 10 times something to the 9th times something, where this is 6x cubed plus 3x plus 1, and this is 18x squared plus 3. Common factor of 3 comes out and makes this 30 times x squared, 6x squared plus 1 times 6x cubed plus 3x plus 1 raised to the 9th power. Sure, that's clearly a 30 right there. There we go. All right, let's move on to this next one where u is going to be a negative 4x, u prime is going to be a negative 4, y is equal to e to the u, y prime is e to the u times u prime, y prime is e to the negative 4x times a negative 4 is equal to a negative 4e to the negative 4x. We did a similar problem in the notes previously. We had y equals e to the negative x. And I said when we learned the chain rule that it would become easier because if u is negative x and du dx or y prime is a negative 1, y is equal to e to the u, y prime is equal to e to the u times du dx or y prime, I'm sorry, u prime, so y prime is equal to e to the negative x times a negative 1 is equal to a negative e to the negative x, and you can go back and look at our notes from last time with that problem. Let's move on down here to this next part of our notes. Combining derivative rules. So the product rule, you can see there in all those nice pretty colors that the derivative of f of x times g of x is equal to f prime times g plus g prime times f. And the quotient rule, the derivative of f of x divided by g of x is equal to f prime times g minus g prime times f all over g squared. And the chain rule here that we have the derivative of f of g of x is equal to f prime of g of x times g prime of x. So let's put it all together and look at our inner function u. It's 5x squared over 3x squared plus 2. And that makes y equal to u to the third. Y prime is equal to 3u squared times, I'm going to say u prime here. So let's figure out u prime, where I'm going to use a quotient rule. For that, that's going to be the derivative with respect to x of 5x squared times 3x squared plus 2 minus the derivative with respect to x of 3x squared plus 2 times 5x squared over 3x squared plus 2 quantity squared. U prime is 10x times 3x squared plus 2 minus 6x times 5x squared all over 3x squared plus 2 quantity squared. U prime is equal to 30x to the third plus 20x minus 30x to the third over 3x squared plus 2 quantity squared is going to be u prime is 20x over 3x squared plus 2 quantity squared. So y prime equals 3 times something squared times something here. And this is 5x squared over 3x squared plus 2. And this is 20x over 3x squared plus 2 quantity squared. So this is y prime is 3 times 25x to the fourth times 20x over 3x squared plus 2. 2 and another 2 makes 4. So we have y prime is equal to 1500 x to the fifth over 3x squared plus 2 to the 4th. And that's it. All right, let's move on to the next one. We have u is equal to x squared, v is equal to x minus 1 to the 1/2 power, u prime is 2x, v prime is 1/2 x minus 1 to the negative 1/2 times 1 because the derivative of the inside is 1. So y prime is going to be u prime v plus v prime u. So it's y equals u times v. Y prime is equal to 2x times x minus 1 to the 1/2 plus 1/2 of x minus 1 to the negative 1/2 times x squared. It's going to give us y prime equals 2x square root of x minus 1 over 1, 2 square root of x minus 1, x squared. Let's make a common denominator here by multiplying here by 2 root x minus 1, like so. Y prime is going to be 4x times x minus 1 plus x squared over 2 root x minus 1. Y prime is going to be 4x squared minus 4x plus x squared over 2 root x minus 1 is a 5x squared minus 4x over 2 root x minus 1. And we can factor just a little bit in the top here, x times 5x minus 4 over 2 root x minus 1. All right. Let's actually rationalize this denominator here. Root x minus 1 over root x minus 1 is going to give us y prime equals x root x minus 1 times 5x minus 4 over 2 times x minus 1. We don't always make you rationalize the denominator in calculus. It's good practice if you don't know if you should do that to rationalize the denominator. Listen to whatever instructions your teacher gives you on whether your teacher tells you to rationalize the denominator or not. And that's it for this video. We'll come back next time and we will talk about derivatives of logarithmic and exponential functions. I'll see you for the next video.